Alright, let's look at the homework 3.3, problem number 9. Alright, so we have the graph of f given, and then we want to find the graph of f prime. Alright, so let's do that. Alright, so if you look at the original f, here, before 0, it's decreasing, which means that the derivative must be 0. Alright, so let's look at the, must be negative, sorry. Alright, so you can see that the before 0, graph has to be below the x-axis. So the first one satisfies that. And look at the second one. See that before 0, this is actually positive. So we can immediately eliminate this one. And also this one, we can eliminate this one. Alright, but the last one, it's a negative here. So that's good. Alright, so it's either first one or the fourth one. So here, between 0 and 2, graph is increasing, which means that the derivative is positive. So you can see that between 0 and 2, it's positive. Right? It's between 0 and 2, it's still positive. But after that, you can see that the original graph is decreasing, which means that the function derivative must be negative. So this one goes below the x-axis, which means that it is negative. But this one doesn't do it. So we know that this is the correct picture. Alright, so let's go ahead and check the answer. Alright, I came back and looks like we have the correct picture. So this is the graph of f prime. Alright, so let's look at part A. Find the open interval on which f prime is positive. Alright, so f prime is positive. Alright, so you can see that it's between 0 and 2. Alright, so we're going to have between 0 and 2. Alright, so let's check the answer. Alright, I came back and looks like we got this one correctly. And describe the corresponding behavior of f. So since that derivative is positive, it means that the f has to be increasing. Alright, so we have that. Alright, let's check the answer. Alright, I came back. It looks like we got the correct choice here too. Alright, let's go to part B. Find the open intervals on which f prime is negative. So everything other than that, so you can see that before 0 and after 2. So we can write it as before 0. So it's going to be a negative infinity to 0. And then after 2, so you have, let's say, I'm going to use a set notation, union, and starting from 2 to infinity. So we're going to use the symbol, and we have that, right? And let's go ahead and answer this one too. Describe the corresponding behavior of f. So if the derivative is negative, it has to be decreasing. All right, let's check the answer. Alright, it came back and it looks like we got part B correctly. Alright, let's move on to part C. Alright, it says that to find the open interval on which f prime is increasing. Alright, f prime is increasing. So here's f prime. So you can see that the increasing all the way up to 1. Right, so we know that this is going to be negative infinity to 1, right? Then if f prime is increasing, by definition, f is going to be concave upward. All right, let's check the answer. All right, I came back and looks like we got part C correctly. All right, let's move on to part D. All right, find the open interval on which f prime is decreasing. All right, so f prime is decreasing after 1. So we know that this is going to be from 1 to infinity, right? Right, so if f prime is decreasing, by definition, f is concave downward. Alright, let's check the answer. Alright, I came back and looks like we got part D correctly as well. Alright, that's it. I hope that this was clear.